So let's use engineering equation solver to solve this problem. We're trying to determine the compressive or tensile forces in the two members, AB and AC. You'll see I've drawn a free body diagram for pin A, and I've assumed that both AB and AC are under tension, and that's to help me get the signs right. So if AB is under tension, I've got FAB acting to the lower right, and if AC is in tension, I've got FAC acting on the pin to the lower right, and I've got the force, some force acting downward, and I've done my my sum of forces in the x and in the y direction and set them both equal to 0. So if I go to engineering equation solver, one thing that I did is I took a screenshot of the diagram, and I can go under Windows, I can go to Diagram Window, and I'll click here and I'll use Control V to paste it in. I'll paste it in as a bitmap. So now I've got a diagram already in engineering equation solver that I can work with or print it out to turn it in. And I just took a screenshot also of the free body diagram for pin A so we can have it handy here. So let's do the sum of forces in the x direction. It's FAB times the cosine of 45 degrees. And note that I've put degrees in these square brackets just to confirm that I'm not working in radians. And here's FAC times the cosine of 30 degrees. And the sum of those will equal 0. And here, to the right of the equation, I'll expand this window, and I'll say this is the sum of forces in the x direction. So let's add in the second equation, where my second equation is the sum of forces in the y direction. Let's start by assuming that that downward force, F, is equal to 500 newtons. So once I've defined it, I'll hit F2 to calculate it, click Continue, and it says I've got one unit problem was detected. So if I check the units, it says that there's something wrong, inconsistent with my formula. So let's see, I'm going to click right here, variable info, and I see what I didn't do was define FAB I expect to be in newtons, and in FAC I also expect to be in newtons. So I'll click OK, rerun it now, and I have no unit problems detected. And this shows me that FAB is a positive value for about 450 newtons, and FAC is a negative value. And by my sign conventions, that means that this member, AC, is under compression because FAC is a negative value, and FAB is equal to 448. If I want to, I'm going to right click here and I'm going to say highlight. Let's put a box around this value. We'll make it yellow. In my secondary units, let's say instead of newtons, I also want it to be reported in pound force. So I'll click there. Now I've highlighted it. Here it is in newtons and in pound force. Let's do the same thing for this one. We'll make it a box with a yellow background, my secondary units of pound force. So if I was to print this out and turn it in, I would go File, Print, and let's include the diagram. Let's not include the actual equations. Let's do the formatted equations, makes them a little bit nicer. And I also want the solution on there. I come up, this is the output of it. Notice it included the diagrams in here for me. It's included the formatted equations. Here's the sum of forces in the x and then in the y direction. And here's the final solution for it. So on here I'd write my student ID number and turn that in. It's an easy way to include the diagrams into your code, and if you wanted to, after you print it out, you could annotate it with pencil or pen or something additional if you wanted. Let's do another variation on this problem, and we'll say that one of the members will break if the tensile or compressive stresses acting on either one exceeds 700 newtons. And we want to figure out how big that downward force can be before it fails. So let's come back over to engineering equation solver. I'm going to come back into my window, and instead of 500 newtons, I'm going to comment this out using my curly braces. And instead of specifying F, let's say that FAB is equal to 700 newtons. And if that's true, it means member AB will fail. So I'll run this, I'll calculate it. Here I've got values now where I've set FAB equal to 700 newtons. That means that it could support a force of about 781 newtons before AB fails. So let's figure out if AC is going to fail. Immediately what I see is that AC is only under compression of about 570 newtons. So it doesn't look like FAC would fail. But let's confirm, and we'll figure out the force needed to make FAC fail. So here I'll change FAB to FAC, and I'll set it under negative 700 newtons. And as we see, this would require a force of about 960 newtons to make AC fail. So indeed, FAB at this force would exceed 700 newtons, and the structure has already failed. So let's make a graph of the tensile or compressive forces on AB and AC. So to do that, I'm going to insert a new parametric table. And let's have, I don't know, 101 runs. And I'm going to include in here my the downward force, FAB and FAC. Click OK on that one. And now I'm going to run my force. Let's run it from 0 newtons up to 1,000 newtons. And I'll click OK on that. So for each one of these runs, I'm going to rerun the code to calculate FAB and FAC as a function of the downward force. So to do that, I'll click play, and it immediately throws an error, and it says, well, I can't calculate it because you've already specified value for FAB. So let's get rid of that. And now I'm going to rerun it, calculate new values for FAB. I'll click play on that, and it shows me the values in newtons and in my alternative force in pound force. Once I've made the table, I'll click a new plot, and on my y-axis I can choose, let's choose FAB and FAC in newtons instead of and not pound force. I will do an automatic update, and let's make some large lines with no symbols on that. So I click OK on this. Here are my y-axes in newtons, and let's double click here, add a 0 line just so we can figure out where 0 is. And let's include a legend. So I'll just say this is FAB, and I'm going to say legend symbol here is the black line. I'll click OK on that. So here's FAB. If I want to, let's add another one. Here's FAC, and the legend symbol here is the blue one. Click OK on that. Let's move FAC down to here. Alternatively, what I could have done is click insert the new plot, and I could click add legend item here and click OK on that, and it'll automatically give me these values. Here I haven't unchecked the data point, so it shows the little circles and the squares. So if I want to print this out and turn it in, I'll go File, Print, and we'll include the diagrams, let's include the formatted equations. I don't want to include the tables because they're large, there's 100 lines long, it's a waste of paper, so let's not include that, but let's include the plots. And when I print that, here's again my diagram, my formatted equations, and on the next page is my plot. If I wanted to, here's FAB would fail, as we saw earlier, failed somewhere just under 800 newtons. And if I want to, I could calculate what it would take for FAC to fail, and this would be something closer to 1,000 newtons.